Morning, I'm Joseph Opati, math teacher Boqol High School. Today we're going to cover the topic indices and further logarithm. Of course, indices is just a preview of what we covered in Form 2, but of course the two topics are connected. So we cover indices just quickly as a way of revision, then see how indices and logarithm will connect. So let's have our introduction. So indices as a topic. Now, we want to first of all begin by clarifying what indices are. Of course, indices is the plural of what? Index. So one is index. When there are many, we call them what? Indices. Now, an index is just a form which a particular number can assume. I'm going to give a small illustration. Now, the moment we have a number like, let's say, 2 times 3 to give us what? 6. We are saying this number here and that number there have assumed different forms. So 2 and 3, or 2 times 3, we say this is a form we call what? A factor form. Now, what about 6? 6, we are saying, has assumed what we call expanded form. Expanded form. So what do you mean by expansion? It's something I've mentioned in the past. Of course, now under what? The topic, quadratic. Expansion is joining smaller units to get a bigger unit. So I'm joining 2 and 3 to get a bigger unit, 6. And of course, when you reverse from 6 to get 2 to 3, we say you do what? You factorize, where we break 6 down into what? 2 and 3. The 2 and the 3 are called factors. Are we together? So we're saying here, to move from here to there, we call it what? Expansion. To move from this back to this, we call it factorization. So in that regard, 6 is said to have assumed the expanded form, while 2 times 3 is said to have assumed what? The factor form. So I want to use this, of course, now to be able to introduce what? The index form. Now consider this. Consider this. We have 2 power 3. Now, that implies you multiply the number 2 by itself 3 times. Now, what do you get? We have 2 times 2 times 2, which in the end will give you what? 8. So here we have a number expressed in 3 different forms. Here, what do you call this? We call it factor form. The number has assumed, of course, or been written in factor form. What about 8? Is something you've talked about. This is expanded form. Now, what about 2 power 3? 2 power 3 now has assumed what we call what? Index form. So in terms of values, we are saying whatever I have here, whatever I have there, and whatever I have there have the same value. But now they have assumed what? Different forms. So we have index form, factor form, expanded form. Now, if you're very keen, a number in index form has two components. The number below here and the number, of course, on top of what? On top of 2. So these numbers have got what? Different, of course, names. Something we want to, of course, discuss. So now let's start our indices. Now you write a number in index form has two components. A number in index form has two components as shown below. A number in index form has two components as shown below. So we have the number below here is called what? A base. The number above there has three names. Of course, the first name is power, or is called index. Index, or is called logarithm. That's why I said index and logarithm are connected. So we have a base here, we have power, index, or logarithm. Let me just mention something, of course, brief about the term power. The term power will just be used to make our work easy in terms of being able to do what? Read these numbers. For example, if I have 3 there, then 4 there. How do you read this? 3 power 4. If I have 6, then I have, let's say, 5. How are you able to read that? This is 6 power 5. So we have 3 power 4, 6 power 5. Are we together? So I'm done with what? The term power. Now, my focus will be now here and there. Now, logarithm will come later. Of course, our focus on it. Now we want to focus on what? Index. One is index. When there are many, we call them what? Indices. So, about indices. Of course, when there are many, I've said one is what? An index. About indices. Whenever we carry out operations in indices, we have what to call what? Laws of indices that we normally use. Laws of indices that we normally use to do what? To carry out operations in indices. Laws of indices. Now, we can have about 9 of them. We discuss each one at a time. Then, of course, give examples, then go to what? The next. Now, the moment you hear about the word law, we normally have what? A condition somewhere. So, if you want to understand these laws, just be able to do what? Note the conditions attached to a particular law. Now, for example, if I give an example of a civil law, maybe you're told if you steal something, you go to jail. Meaning the condition of going to jail will be stealing something. If you don't steal, you don't go to jail. Let's talk about other laws that we have discussed in the past. For example, a law in physics called Hooke's law. Hooke's law states that what? For any helical spring or an elastic material, the force is proportional to the extension provided elastic limit is not exceeded. So in that law, what is the condition? Provided elastic limit is not exceeded. Are we together? So you're saying even for the laws of indices, you must be very keen to note what? The condition attached to a particular law. So we want to discuss those laws, one of course at a time. So we discuss the first law. I call it law 1. This is a law that, of course, now is concerned with multiplication of numbers to a similar base. And this is how I'm going to state the law. So we have x power n times x power m. You get x power n plus m. So for this law, what are the conditions? There are two. Number one, there must be what? Multiplication. Multiplication is the operation there. Number two, the bases must be what? Be the same. Now, once those conditions are in place, what do? We are saying you add what? You add the powers or the indices. A simple illustration before now, I give an example. We have 2 power 3 times 2 power 1. Now, what is the implication of 2 power 3? We are saying we are multiplying 2 by itself 3 times. Then we have our times there. Then we have what? 2, of course, power 1. In overall, we have 2 by itself how many times? 1, 2, 3, 4. What do we get? 2 by itself 4 times. Now we are saying this outcome can be achieved by simply applying that law, because we have what? The same base, and we have what? Multiplication. So having the same base and we're multiplying, what do? We are saying you add what? The powers to give you. Of course, now let me just clearly outline the steps before I give the final results. The workout will be 3 plus 1, of course, addition of the powers. Then we get what? 2 power 4. So what is the law here? The law is whenever you multiply and the base are the same, what do? You add the powers. So based on that illustration, let's do some 2 or 3 examples. Now, so what I can call maybe quiz. Let's have quiz 1. Quiz 1, the question is simplify. Simplify the following. Of course, based on the first law we have discussed, let us have Roman 1 of quiz 1 being what? 2 power 4 times 2 power 6. And Roman 2, let us have 3 power 5 times 3 power negative 2. So based on that first law we have discussed, what will be the outcome of this, of course, workouts? So 2 power 4 times 2 power 6, we are saying the operation is multiplication, the base are the same. So what do we get? 2 power 4 plus 6. In the end, you end up with what? 2 power 10. Of course, now assuming maybe the requirement was you give your answer as, of course, you leave your answer in index form. Now here we have again the same procedure. The condition is that we are multiplying and the base are the same, meaning now the first law will be applicable. So we have 5 plus negative 2. Of course, from your indices, that will come to 5 minus 2. In the end, what do we have? 3 power 3. That was the first law. So how do you remember it? It's a law of multiplication having what? The same base. Now we go to what? The second law. Law number 2. And law number 2, I give the law, then we discuss what? The conditions in the law. Now, law number 2, we have x power n divided by x power m is equal to x power n minus m. So for this law, what are the conditions? 2 conditions. Number 1, the base must be similar. Number 2, the operation must be division. So what do? You subtract. So again I give illustration, then examples. Now we have 3 power 5 divided by 3 power 2. Now this means, of course, this can translate to 3 power 5 over 3 power 2. If you are very keen, 3 power 5 means what? 3 multiplied by itself, of course, 5 times. And then 3 power 2 as our denominator means 3 by itself twice. Then we have the common factor cancelling out. Now what are we left with? We are left with 3 power 1, 2, 3. It gives you what? 3 power 3. Now we're just saying the same outcome of 3 power 3 can be achieved by simply employing what? That law of division. Of course, when we have what? Similar base. Now what will I do? I will say I'm having 3 power 5 divided by 3 power 3. So having similar bases and the operation is division, what do? We subtract the powers. This will give you what? 3 power 2. That should be, I made a mistake here, sorry. Initially we had what? 2, meaning we shall get what? 3 power 3. Okay. If you're very keen, the outcome here is the same. So what are we saying? In regard to law number 2, whenever you divide and the bases are the same, what do? Subtract the powers or indices. So again, in that connection, I will give some 2 or maybe just 3 examples. Now, quiz number 2, based on law number 2. So we have quiz 2. So what is the question here? Question is simplify the following. So we'll have Roman 1. Let's have 5 power 4 divided by 5 power 2. And Roman 2, let us have maybe 7 power 3 divided by 7 power negative 2. So what will be the final results? We are saying the base are the same, the operation is division. So what do? We subtract the powers. So we have 5 power 4 minus 2. The end result, we get what? 5 power 2 or 5 squared. What about here? Of course, don't forget what you were taught in indices in form 1. Here we shall have 7 power 3 minus negative 2, which in the end will come to 7 power 3 plus 2 to give you what? 7 power 5. So we are done with the first two laws. So how do you recall the first law? It is a law of what? Multiplication having the same base. What about law number 2? Law number 2 is a law of division having what? The same base again. Now let's go to our third law. Our third law is actually a law of multiplication, a law of multiplication having the same power. Remember, the first case we had what? Law of multiplication having the same base. Number 2 was law of division having what? The same base. What do we have here? A law of multiplication having what? The same power. What do you do? This will be the outcome. The outcome will be the product of the bases. What do we have? X, Y. And then that product would assume that similar power. So you get x power n times y power n. What do you get? Xy power n. I just want to give illustration to verify that. Now, if we have 3 power 2 times 2 power 2 based on this law, what shall we have? I will take 3 times 2 to give me 6. And then the 6 is, we'll assume that similar power 2. And of course, we want to prove this. How do you prove it? 3 squared on its own is what? 9. 2 squared is what? 4. So 9 times 4, what do you get? You get 36. What about 6 squared? 6 squared gives you what? 36. Are we together? Meaning this is a valid law. So whenever you multiply numbers to a similar power, what do? We are saying you can do what? You actually take the bases, multiply them, and then whatever product you get should assume that similar power which exists. Now, there was this question asked by a student in terms of such a question. Now, you get a question like this: 2 power 3 times 2 power 3. We have the same base, we have what? The same power. So in this case, which one now, which law do you use? Do you use law 1 or law 3? In this case, I think both laws will be able to give you what? The same answer. Now, if we were to use what? The first law, where now we say the base are similar, and we have what? Multiplication. What happens? We add what? The powers. What shall we get? 2 power 3 plus 3. What do you get? 2 power 6. Now, using your calculator, what is the power, the value of 2 power 6? 2 power 6? Yeah? 64. Okay. Let us see that. So we're saying what? The outcome is 64. Using which law? Using the first law, where the bases are similar and the operation is multiplication. Now, what about if we decide to use what? The third law, where we are saying we do what? We apply the law of multiplication having the same power. What shall we get? We are having 2 power 3 times 2 power 3. I multiply the bases to give me what? 4. Let that 4 assume that similar power, 4 power 3. Do you have the same outcome? Verify that. We get what? The same outcome. Are we together? So we're saying when you have such a case You can either apply the first law or the third law. So the first law was a law of what? Multiplication having what? The same base. The third law, a law of multiplication having what? The same power. Is that okay? Now we can go to what? The fourth law. Now, I think before we go to the fourth law, I must be fair to this law. Let me give examples. We have what? Quiz. Quiz 3. Of course, now a quiz in relation to our what? Our third law. Now, the question is similar, of course, in terms of the way it has been framed to the other previous question. So simplify the following. Roman 1, what do we have? We have t power n times h power n. Roman 2, we have 5 power 3 times 2 power 3, and maybe Roman 3, of course, in regard to this third law, we have 7 power 2 times 5 power 2. So what do you get in this case? We are saying the powers are the same. Operation is multiplication. So what shall we get? We shall have t h and then power n. That's similar power appearing there. What about here? We have 5 times 2 to give us what? 10 power 3. Our last, of course, example, again, the conditions for the third law exist. Which are the conditions? The operation is multiplication and the powers are similar. So what do we get? 35. How do you get this? 7 times 5 to power 2. That becomes your eventual answer. So far we have seen how many laws? 3 laws. Number 1, law of multiplication having the same bases. Basis actually. Roman 2, law number 2, the law of division having the same basis, and law number 3, the law of multiplication having the same power. Now we can go to what? Our fourth law. Our fourth law. Okay, law number 4. Now we state the law, then discuss the condition for the law to be applicable. Now this is the law in terms of how we state it. X power n divided by y power n is equal to x over y power n. What are the conditions? Same power, and then operation is what? Division. So dividing numbers to a similar power. Again, just as an illustration to verify that, then I give what? Examples. Illustration, let me have talk about 10 squared over 5 squared. Of course, now working without the application of this law, what is supposed to be our outcome? 10 squared would give us what? 100. 5 squared would give us 25. In the end, that division will give us what? An outcome of 4. Now what about applying this law? because I'm insisting the condition for the application of this law exists here. Which are the condition? We are dividing, and then the powers are the same. So with this application give us the same outcome of 4. Of course, let's see how that will be. So we have 10 squared divided by what? 5 squared. We are saying based on this law, how would you proceed? We shall have 10 over 5 squared. Then work out what is inside the bracket. 10 over 5 gives you what? Gives you 2. Then you have what? 2 squared. In the end, we get what? 4. Virtually the same outcome we got here. So here, just using normal division, here, of course, now applying the law of division, having the same power. So far we've seen how many laws? 4 laws. Which was the first law? The law of multiplication having the same basis. Number 2, the law of division having the same basis. Number 3, the law of multiplication having the same powers. And now we're looking at what? The law of division having what? The same power. Now let me do justice to this law by giving what? Quiz number 4. Now we look at quiz number 4 in regard to what? Our 4th law. So the question is again, simplify. Simplify the following. Roman 1, let me have t power x times h, not times, sorry, we are dealing with division, sorry for that, divide by y power x. Roman 2, let me have 6 power 3 divided by 2 power 3. So what shall we get? Of course, now in relation to this 4th law, then let me lastly have 12 power 4 divided by, of course, let me say 6 power 4. So for the first question, t power x divided by y power x, what shall we get? We shall get t over y to the power of x. The second, what shall we get? 6 over 2 power 3. Then go ahead and do what? Simplify whatever is inside the bracket. What do we get? Of course, we get 3 power 3. Of course, as our final answer. Now, assuming now we wanted you to give your answer in index form. If at all there's a different condition, for example, you give your final answer as the expanded form, it should be 27. What about here? We have 12 over 6 to the power of 4. This will give you what? 2 power 4. Of course, now 2 coming from simplification of what is inside this bracket. So we are done with the first 4 laws. We have 5 more to go. Again, a quick recap of the laws. I want you to master them. The first law was what? Law of multiplication having the same basis. Number 2, law of division having the same basis. And number 3, law of multiplication having same powers. And then number 4, law of division having what? The same, of course, we say what? The same power. Now, we go to our 5th law. The 5th law, discuss it, see what the law entails. The 5th law is a law whereby you have been given a number in index form, and that number in index form is being raised to another power. This is law what? Law number what? Number 5. Okay, law number 5. So we have x power n. Already x power n is in index form, but now we are raising that to a power m. So what do you get? Your outcome will be x power nm. How do you get nm? Simply multiply that index by that index. Both are powers or both are indices. Multiply n by m. Again, I give an illustration, then we go to what? Examples. Illustration, I have 3 power 3, then raised to power 2. Now, using a long argument, this implies that we have what? 3 power 3 by itself. Of course, now, twice. Now, let me apply the first law of what? Multiplication having numbers to a similar base. It means I'm going to do what? Add 3 plus 3, which are the indices, to give me overall outcome of 3 power 6. We are saying the same outcome can be achieved by simply multiplying 2 and 3 to give you what? 3 power 6. So given 3 power 3 raised to a power 2, we take what? 3 power 3 times 2 to give you what? The same outcome. That is law number 5. So again, I be fair. Let me discuss what? Give a quiz in this, of course, regard. Now, quiz 5, based on the 5th law, quickly. Quiz 5. You are told to simplify the following. Now, Roman 1, we have 5 power 4 raised to power 3. Roman 2, let me have it in this position. We have 6 power 4 raised to power 3. Let me have it as 3 over 4. Lastly, I'll have 7 power 4 raised to power negative 3 over 2. So, based on that law number 5, what will be the outcome here? We are saying you multiply 4 and 3 to give you the final answer as 5 power 12. What about what we have here? You take the 4 times 3 over 4 to give you what? Of course, let me do it from here. So 4 times 3 over 4. Those are common factors. We have 3 left. After that simplification, what we have? 6 power 3 in the end. What about here? we have 4 times negative 3 over 2. So 2 goes here 1, 2 goes here 2. So what do you get? Negative 6. What do you end up with? 7 power negative 6. So those are the what? Solutions to those given questions based on law number 5. Now, before I go to law number 6, we have an issue I want to discuss here, which is a common mistake by most students, depending on maybe how you arrange your work in a given exam, of course, or maybe even during your classwork. Now, for you to be guaranteed full marks, we need to avoid errors. Let me give an example of such an error you make. And of course, I want to emphasize on that. It's a common mistake you make. Now, you've been given such a question as 6 power 4. And then let me have that raised to power 3 over 4. You are supposed to simplify. Now, a number of you approach this question in this manner. Somebody will say this is equal to, it takes 4 times 3 over 4 to get what? 3. Then they give the answer as what? 6 power, of course, 3. Now, this is very wrong, because you're saying this is what I call what? A wrong mathematical statement. Whatever we have here, there and there are not in any way equal. Therefore, this is wrong. So how you arrange your work, of course, now determines, of course, the maximum score you get in that question. So this question you're saying it was what? 6 power 4 raised to power what? 3 over 4. Now this can be a good approach. You just go to your next step and show that it is 6 power 4 times 3 over 4. Simplify this at this point. What do you get? 6 power 3. Or you can take the power and work out them in a separate, of course, now space. Then whatever outcome you get as 3, you bring it here and do what? Place it there as a power of 6. Avoid that. Having what? Wrong mathematical statements. Another mistake is this. You give a student such a question as 6 power 4 and then raise it to the power, let me talk about, let's say 5 over 6. So what should be the workout on the eventual answer? We should have 6 power 4 times 5 over 6. If you're very keen, if you simplify this, 2 goes there, 2. 2 goes there, 3. Now having exhausted the common factor, what should be the eventual answer? Multiply 2 and 5 to give you what? 10. We should have 6 power 10 over 3. But the moment now you present your answer as this, 6 10 over 3, that becomes wrong. That is like 6 whole number 10 over 3. We are saying the position of the index should be above 6. So avoid this mistake. Are we together? Good. We are done with how many laws? 5 laws. And of course, we have done our best to make sure we give relevant examples after discussion of each law. So again, I want to be sure we are together. How many laws have we discussed? 5. The first law was the law of what? Multiplication. In fact, let me just put them down before I clear with the other 4 remaining laws. Law number 1, it was a law of multiplication having the same basis. What should be the outcome here? You add the powers. Law number 2 was in regard to what? Division of numbers having what? The same basis. What do you do here? We are saying you subtract the powers. We had our third law being law of multiplication having the same powers. What do? You multiply the bases and let that product you obtain to assume that similar power. Then our fourth law was in regard to division having what? The same power. What are we getting? Division, of course, or quotient of the bases involved, and then that quotient assumes that similar power. And then we finish with what? Law number 5. That is the law of an index being raised to, of course, a power. What do you get? The base raised to what? The product of the indices. Those are what? The first 5 laws. So I'm insisting you want to recall the laws. Remember what? The condition. Here the condition is what? Multiplication, same base. If at all those conditions do not exist, don't apply what? That law. For example, you can be given such a question. 3 power 2 plus 3 power 3. Now, you find a number of students making a mistake and applying that law. Now, this law is not applicable there. Why? Now, as much as we can see clearly, there are the same bases. The operation here is what? A plus and not a multiplication. So in this case, what do? You work out this index here separately to give you 9. That one separately to give you what? 27. Then put them together by adding them to give you what? 36. So I'm insisting you want to be okay with this topic. Master what? The law and its corresponding condition. So here condition is we are multiplying. The base are the same. Here we are dividing. The bases are the same. What about here? We are multiplying. The powers are the same. Then here we are dividing. The bases, the powers are the same. Lastly here, we are having an index being raised to another power. Is it okay? So we are done with the first 5 laws. So how many are left? We are left with 4 more laws, which I think we shall be able to do what? Exhaust in our next class. Okay.